Okay, so a couple of students have asked if we can have a tutorial for how to do machine learning for image classification in C#. We'll look at the theory behind that and the practical behind that. The first stage is to gather some training data. This is very limited. We've only got 5 images here, so the quality of our AI machine learning predictions is going to be pretty questionable at best. But obviously, I think you should not rely on AI before deciding whether or not you should eat edible or poisonous things in the first place. So it's important that you record your sources for copyright reasons and for you to be able to refer back afterwards. I am going to save each of these as pictures so that we can use them to train. I've created a folder with 2 subfolders. You can have as many classes as you like, but you have to have at least 2 different ones. I'm not going to name them, I'm just going to give them numbers. So, oh, that looks tasty. Save as picture. There we go. The reason I'm putting them into PowerPoint is because if you just get them from Google Images and save them, it might try and be a WebP. PowerPoint is a nice quick way of displaying them. And then we'll do the same for the poisonous ones, but making sure that they're in separate folders. You'll see why they need to be in separate folders later. It makes it an awful lot easier for your training and also for your organization. If I was doing this properly, I'd probably have a spreadsheet with all of the sources on here. But I think this is fine for now, just to keep track of where all of these images are. So our next stage, we're going to use Teachable Machine to show you very quickly what we're aiming for. It is theoretically possible to be able to interact with that with a C# project, but it's not easy, so we'll show you a different way to do that. But we'll do an image project, we'll go standard image model, we'll go for edible. You name your classes in here. The more classes you have, the longer it takes to train. The more training data you have, the more reliable it is, but the longer it takes to train as well. Poisonous. There we go. So this is one reason why it was useful to organize all of your files in a folder. Which one was this? This was the edible one, because you can just select them all, add them all in. Backspace, poisonous, there we go. And then we hit train. Now you'll notice this does not take a particularly long time to train. So what's happening here? Is it going from scratch, from first principles, understanding the images? Well, no, it's not. If you look at the details behind the scenes in Teachable Machine, they say that this is reinforcement learning. They start with a model that spent thousands, if not millions of hours of GPU time to classify images using a well-defined training data set. And then this is reinforcement learning, where you just put an extra layer on top of the neural network that makes this work to try and classify between these two. Don't know if we've got a webcam plugged in at the moment, possibly not. So let's have a look. Let's try it with one of the training models, and it should recognize that this is poisonous because that's part of the training data. But let's try a different model. Let's try, oh, I don't know, a chestnut mushroom. Chestnut. Let's find a picture. Let's save a picture and see if it works. That looks like a chestnut mushroom to me. So I probably should have done this in advance. Let's put this on here. At least you can see the process. Make sure that your URLs don't say Google in them. You say, oops. They say actually where the image was from. Keyboard shortcuts are Control, Shift, and comma to make stuff smaller, or Shift and arrow keys to make stuff smaller. All right, let's save it as a picture. Control, Shift, N, test data. And I would avoid naming it chestnut mushroom, just so that there's no possibility for it to try and guess what it is from the file name. See if it's going to work. We go up one, test data. Ah, interesting. It thinks these are edible. I wouldn't trust it, but that is interesting. Probably because it looks most like a cheeseburger. But let's try something completely and utterly different. How about a poodle? I wonder what's going to happen here. Edible or poisonous? Don't know. place your bets now. Let's see. Come on. Right, so we need the URL of where this test data is. I'm not advocating eating dogs. Please don't send me hate mail. Let's see. Save that picture. And let's try. Is it poisonous or is it edible? There's some debate, but according to this very limited training data set, it says it's edible. So in the theory unit of your A-level, we talk about bias and limited training sets. I hope you can visualize that this is very limited. If you wanted it to be accurate, you'd need thousands of images, but that would take a long time to train. Okay, so that's the first part of the concept here. This is reinforcement learning. How do we do that in Visual Studio? Well, if you're doing this at home, you need to make sure you've got the model builder installed. How do we do that? Well, on Visual Studio Installer, I've asked the technicians in school to install this already, so it should be there for you in school. If we modify Visual Studio Community Edition and then ask for the individual components and search for model, you should have the machinelearning.net model builder. That's the one that we need. If you've got an NVIDIA GPU, you can search online for details on how you can accelerate it and make it run much faster for image classification. But in school, I think we're just using the CPU rather than the GPU, and you can understand that that will be much, much, much slower because we can't do it all in parallel using the many, many compute units. Right, we'll start with a console application. And then we'll learn how to be able to link that to a Windows Forms application if we get that far. Might not be in this video, in this session, but we'll see. I'll put this in year 13. And let's call it editable, or not. Okay, so a console-based application is just going to run in a window. We want something that's as easy as possible with as few lines as possible to be able to make a prediction. We want to be able to give it a file that we can load from a file. We'll do that in a command line window first, and then we'll work out how we can do that in a graphical user interface form when it's done. So what do I want to be able to do? I want to be able to load an image from a file. Predict editability. Is that a word? Don't know. I'm not going to say whether you'll die. And display the results. Okay, so we've done some decomposition. How do we do that? Well, if we right-click on your project and we should be able to add a new machine learning model. That's what the plugin for Visual Studio allows us to be able to do. There are all sorts of different types of machine learning model. We need to give it a name first, and this file is going to store all of the training data and all of the code and all the classes created. So it makes sense to name it something related to the model. So I'm going to say poison detector. You then get a really nice user interface, a little bit like Google's Teachable Machine interface. You can do this just with text data or numerical data. We're interested in image classification. You can train it online, but you'll have to pay for that. I think as a student, if you put in your credit card details, you can get a year's worth of free cloud computing space. So if you really wanted to do that, you could, but we're going to do it all locally, both for data protection reasons and also for speed reasons. We'll train locally. This computer does have a really terrible NVIDIA GPU, but we don't have CUDA installed. You need a very specific version installed. If you have a later one, this is not the latest version, it's not going to work. So I'm just going to train it with a CPU. And let's go next step. All right, another reason why we needed to organize our data in this folder. So let's load that data. I put it on the C drive, and it was food. So inside here, I've got 3 folders. I don't want to include test data at this point. Can we edit it after we do that? There are less than 5 images yet. So has it ignored that? Can we remove that? Or can we do that again? Let's try again. I'm going to move that test data folder up one, so it's not part of my training data. Interesting, I can't move it. Why not? It must be open. Maybe it's open here. Try again. Nope, maybe it's open here. If not, I'll just copy the folders that I need. Oh, there we go. It was PowerPoint that was messing it up. So there we go. Just got folders now for the categories, the classifications of data that we want to work with. This should be better. More than 5 images is strongly recommended, but this is just an illustration to make it nice and fast. And the more limited you can be, the more accurate you're going to be. For example, we've got burgers and yogurts. It would make sense to have your classes really locked down and limited if you want any chance of success. Then we sit down and relax. It might take a wee while. The actual training doesn't take a huge amount of time, but NuGet packages are being installed. What's happening here? It's installing machinelearning.net NuGet package. It's installing TensorFlow, and TensorFlow is the library that machinelearning.net C# is going to use for this. Then it's going to have a number of generations worth of reinforcement learning, where you start with a pre-learned model trained on a very large image data set, and then you're going to just cut it down to the classes that you've defined on top of that, and repeat that until you get a level of accuracy with just the training data. Normally it takes about 1 minute to 2 minutes for me with a limited number of things. It will tell you when it's done. But the clever thing is, this is going to generate all of the code that you need to be able to make this work. Good, we've got a little tick. Look at that for usability. That's nice, isn't it? Little green tick, status bar message, more detail down here. We like that. Next step, right, let's test it. So we'll browse an image. Don't use, well, we could use an image from the training set. How long is it going to take? So it's not instantaneous. AI does take a while to be able to load the data, process the data, put it through the machine learning model, and get a result. It is not going to be instantaneous, even if it's local. If it's done on the GPU, it'll be a little bit faster, but that's a bit concerning. It's not managed to compute this. I wonder why. Let's try a different one. Come on. Should be able to do this. Okay, so this didn't work for me. It wasn't very conclusive. So we're going to need a better set of training data. I'm going to use one I did with Year 8. I asked them to research people they thought of as heroes and people they thought of as villains. So we're going to have to completely retrain this. I've only got 4 heroes here. You might recognize some. And we've got some villains. I didn't choose these. These were by Year 8 students. Let's train again and hope for the best. I'm going to pause the video and let's see. So let's have a look. Let's try it with some of the training data. One of the villains, I didn't choose this. This is not a political point. Will it give? Oh, it's not worked again. Well, we're going to pause this video here. I'll resume when we've got a working model. I suspect we need a much larger data set for it to be able to work. But hopefully you've gone through how to set up the image classification, a little bit of an insight into what happens. You might want to research reinforcement learning, find out more details about the actual model that it's built on top of, collect your data sets, and in the next video we'll pick this up and try and make it work.